Okay, and Fundamental Theorem of Calculus Part 2. Now, this is pretty self-explanatory. What it's really saying to you when you boil it all down is just the derivative and the antiderivative are inverses. So therefore, whatever one does, the other one undoes. So what's going on here is they're saying, like, let's say if capital A of x is equal to all of this. So what they're saying is, okay, you find the antiderivative of f of x, and you find, the capital F evaluated at x minus the capital F evaluated at a, okay? And they're saying it's not f of x, it's f of t, just because they're trying to use separate variables. So you don't say, how am I integrating over x, then substituting in x. So, but it's a little mathy, and don't worry about it. The real thing, what we're trying to get at here, is they're saying, okay, let a of x be equal to this function. Okay, then what we can say is the derivative of this, the derivative dx of that function, well, the derivative of this, well, that would be the derivative of capital F minus the derivative at some value a, and since that's a constant, that would become 0. So therefore, that would leave us with the derivative capital F prime of x, and we know the other notation. Instead of using capital F, that would be lowercase f. All right, so really super mathy, really super much harder than it needs to be. So let's do a problem so you can kind of see it happen in action, and I will help you with this one now. So let me tell you right here, capital F of t would be t to the 5th divided by 5 minus 3t squared divided by 2. Okay, so let's do this in steps. The first thing we're going to do is do the antiderivative of this function and evaluate it at x and a. Okay, so here we go. Step 1. We're gonna leave the dx on the outside. We're gonna do that later. Okay, so the antiderivative would be t to the 5th divided by 5 minus 3t squared divided by 2, going from a to x. All right, now, the next thing we're going to do is we're not going to do our derivative yet. We're actually going to evaluate this stuff. So we're going to substitute in. So it's going to be x to the 5th divided by 5 minus 3 times x squared divided by 2. That's my first part. Minus my second part. Now let's substitute in our a. So this would be a to the 5th divided by 5 minus 3 times a squared divided by 2. Okay. And we could go ahead and simplify. Well, there's really not much to simplify, to be honest, because we have an a squared. We could rewrite this as a squared. Okay, that's about as good as we can do. We could distribute this negative sign through if you really want. And so we might as well. Let's clean that up just as much as we possibly can, make it as least confusing as possible. So this would be x to the 5th divided by 5 minus 3x squared divided by 2 minus a to the 5th divided by 5 plus 3a squared divided by 2. Okay, so now what this notation here is saying is now it's time to do our derivative. Do the derivative of the stuff on the inside where x is your variable. Okay, so what this is saying is bring the 5 out to the front. So that'd be 5 times x to the 4th divided by 5 minus, bring the 2 out to the front, so that'd be 3 times 2x divided by 2 minus, now there's no x's. X's are a variable, so 0, 0. Those aren't functions of x's. Those are constants. So now let's simplify as much as we can. That 5 divides with the 5, the 2 divides with the 2, leaving me with x to the 4th minus 3x. And if we look back to the very beginning, you'll notice what we started with as our lowercase f of x, what we were doing the integral of. X to the 4th minus 3x, t to the 4th minus 3t. So the idea here is what we now have is f of x. So what they're saying here essentially is, I'll give you another quick here. The derivative of an integration of any function, since these two symbols are literally opposites, derivative says do the derivative, This integral means do the antiderivative. Those two things, I hate the word cancel, but they undo. They're inverse operators. So therefore, I am just left with f of x. Okay, that's what the second part of the fundamental theorem of calculus is really getting at, is just these are inverse operators. Whatever one does, the other one undoes. Don't get too caught up with the a's and the t's and the whatever. That disappears after this section, and I really don't care. What I really care about is just that you get the inverse operator idea. Okay, hope that helps.